Hello everyone, so this is section 1.4, which is perimeter and area in the coordinate plane. We are also going to talk about a little bit about circumference and circles today. The objective, take a look at the objective here, find perimeters and areas of polygons in the coordinate plane. Guys, remember how important it is to take notes, right? So grab your notebooks, grab your pencils. Here's your vocab if you like to keep flashcards to keep reviewing them. There's our key vocab words for this section, okay? Let's take a look and define some of those vocab words here. Perimeter and area, I'm assuming these are pretty much review, but if we like a definition, perimeter is the sum of the lengths of the sides of a polygon, right? An area is the space a polygon encloses. The area is the space inside a shape. We need to know some formulas for perimeter and area. So these are the perimeters you might also want to keep on flashcards or jot them down to make sure we know. Perimeter, that's what P is, right? P is for perimeter on all of these. Add up all the sides, right? Whether we're on a triangle, a square, or a rectangle. There's shortcuts, right? Perimeter for a square is 4 times the side because they're all the same, right? And perimeter is 2L because the lengths are the same and the widths plus 2W, the widths are the same. That should be pretty much review, but jot it down if we need. And the area, we know for area for a rectangle, that's length times our width. Area, again, is length times width. We can call it S squared because you know they're the same in a square, right? All sides are the same. And the triangle, this might be a reminder, area equals 1/2 base times the height. A reminder about height here, guys. The height has to be from the top of the triangle to perpendicular to the base, okay? Dropping a perpendicular line from the very top of the triangle, perpendicular, which forms a right angle with the base of the triangle. So it's really important. That's how we find the height, okay? It's a line that goes from the top to the base. Something that we need to notice here is we are going to use these formulas to find perimeter and area, but we are also going to use distance formula to find perimeters and areas. So let's take a second here and remind ourselves of the distance formulas, right? We did those in 1.3. So we have the distance formula for points on the coordinate plane. Is the distance equals that big one, the square root of x2 minus x1 squared plus y2 minus y1 squared. That's for points on a coordinate plane. And then the other distance formula we've been using when it's points on a number line is the absolute value of x2 minus x1. That's when it's on a number line. So we want to make sure we're going to use them. Remember how important it is we're going to build on previous sections. So we're going to use those formulas again in this section. Here we go. Let's take a look at this first example here. It wants us to find the perimeter of this triangle. So already, perimeter, I'm thinking, okay, I got to add up the sides, right? They give us the corners, the vertices, that's another word for corners, of this polygon, of this triangle. Perimeter, that means I'm going to need to find this length. We'll call that AB, the length of segment AB. I'm going to need to find this length, the length of segment CB. And guys, I'm going to need to find this segment, the length of that segment, AC. Okay? Remember, then perimeter, I can add them all together. Okay? Which one should we do first? Let's do CB. I'm going to do CB. I'm going to highlight to focus. Here's on CB. Which am I going to use? Which distance formula am I going to use? The one for a coordinate plane or the one for numbers on a number line? I'm going to use this one because take a look. CB is a horizontal line. Whenever we're on a horizontal line, we want to use that formula on a number line, right? Number line is horizontal. So CB, I'm going to label, and I'm just looking at our x's. We'll do x1 and x2. absolute value of, I can write this out, x2 minus x1. So then we'll say the absolute value of 3 minus negative 2 equals the absolute value of 5, right? 3 minus a negative 2 equals the absolute value of 5, which is 5. Here, that length is 5. Not done, right? I need to find another length. Let's now find the length of, I don't know, let's do AC. Guys, we can, again, use that distance formula, but I also want to show you a little cheat sheet here. We can count up those tick marks, right? And when we do that, we want to kind of hop. So I want to go 1, 2, 3, 4, 5, 6. AC equals 6. Another way we can do it. I showed you 2 ways. A, B, how am I going to use? There's only one way. How am I going to find that length? Which distance formula am I going to use? Hopefully you're thinking this one. And we're thinking this one because it's on the diagonal there. Okay, because it's on the diagonal. I'm going to give us more room because we might need it. And now we can get started. We need to write down that formula because it's just going to help us organize our thoughts a little bit more. So square root of x2 minus x1 squared plus y2 minus y1 squared. My points are A and B. I'm going to go ahead and label them. Always label x1, y1, x2, y2. Look, it was already labeled. And now we'll continue to find the length of AB equals the square root of x2. What's my x2? 3 minus my x1, negative 2. So I'm going to write plus 2, right? Subtract a negative gives me a positive. Y2 is negative 3 minus y1 is 3 squared. Okay? We'll keep simplifying. The length of AB equals 3 plus 2 gives me 5 squared, plus negative 3 minus 3 is 0, right? So I'm going to have 0, negative 3 minus 3, that I'm subtracting a negative, so it becomes a negative 6, right? Negative 3 minus 3 gives me a negative, I'm going to put that in parentheses, negative 6 squared. Wow, totally just had a brain loss memory there. And then what we're going to do is continue to simplify that. I think I need more room. And then we will have 5 squared, which gives me 25, the square root of 25, plus negative 6 squared. Negative 6 times negative 6 gives me a positive 36. Then we can finally add them. AB equals 25 plus 36 is going to give me the square root of 61, and we can round that, and it's going to be about 7.81 is the length of AB. So backtrack, we found 3 things just then, 3 different ways depending on the length of the type of line we were looking at. Find the perimeter. I now need to go back and add all of my lengths of the sides. So I'm going to have 7.81 plus 5 plus 6 equals 18.81 units is my perimeter. Okay, guys, that's how we're going to find the perimeter of a triangle. How about we jump to finding the area of a triangle? Okay, area of a triangle, I'm going to jot down that formula. Area equals 1/2 base times height. Okay, so I need to find the base. Where is my base on this triangle here? Base is at the bottom, so here's my base. And I can go ahead and find that. Let's do that, and I'm going to write the base equals FE. And it's a straight line like that, so I'm going to use the absolute value of x2 minus x1. Here is my x1. Here is my x2. Absolute value of 4 minus negative 4 becomes 4 plus 4, gives me absolute value of 8, which is 8. So I can now come up here and say area equals 1/2 times my base, which is 8. And now I need to find my height. Remember what I said earlier. we find the height. Where is my height? It starts at the very top, and I drop the perpendicular down to the bottom. Okay? A vertical line, guys, I'm just going to use those tick marks, the jumps. 1, 2, 3, 4, 5, 6. H equals 6. Okay? Come back over here to my formula. Area equals 1/2 times my 8 is my base times my height, which I know is 6. And guys, we need to be able to solve this right here kind of by hand. And it's easy. Let me show you. 1/2 times 8 times 6. Let me do that 8 times 6 first, right? 8 times 6 is going to give me 48. And now, guys, 48 divided by 2. 1/2 times 48 is just 48 divided by 2 is going to give me 24 units squared. There's my area. Okay? There is how we find area of a triangle using that formula, talking about distances a lot. I'm going to do one more here. And it's the best one ever. There's my dog. He's so cute. He's a little puppy in that picture. Here we go. You want to frame a picture that is 5 by 7. So here's 5 by 7 with a 1-inch wide frame. Okay, so here's my picture. I have a 1-inch wide frame around my photo. What is the perimeter of the picture? So the picture itself, that's talking about this perimeter right here of the picture itself. So A, my perimeter of a rectangle we know is 2L plus 2W. Well, they told us my length is 7, my width is 5. So I'm going to go perimeter equals 2 times 7 plus 2 times my width, which is 5. 2 times 7, 14 plus 10. 24 inches is my perimeter of the picture itself, right? Now, B says, what is the perimeter of the outside edge of the frame? This is where we really have to think. Outside edge of the frame is now talking about, let me clear, oh no, we'll just stay here, is now talking about this. How wide was the frame? Do you remember how wide the frame was? 1 inch on both sides, right? I can go ahead and say this piece is 1 inch, and then I have 7 inches. That's the length of the picture, and then I have 1 more inch. So now, what is my new length? 1 plus 7 plus 1 gives me 9 is my length. Same thing in my width, guys. I have a 5 inches wide, 5-inch wide photo. My frame is 1 inch over here, 1 inch over here. What is my new width of the entire frame in the picture? 7. Okay, here we'll now find the perimeter equals 2 times my length of the entire thing now is 9, plus 2 times my new width is 7, equals 2 times 9 gives me 18 plus 14. We are looking at 32 inches, 32-inch perimeter of the photo and the frame itself. Okay, guys, so here's that same concept of perimeter, but now in a real world concept. Great job, guys. One more video after this. You guys rock.